welcome to Khetz Tutorials, and in this video I'll be talking about identity operators. So let's call this file identity.py. Now, do you know the importance of memory when dealing with electronic components? But more specifically, your PC. A lot of things are being stored in your PC. Some of them are stored even beyond you switching the PC off, and some things just basically get erased as soon as you switch your PC off. Now, the reason I brought that up is when we talk about identity operators, we are talking about memory locations, or we're talking about, let's look at them as boxes. So let's try to make this as simple as possible. When you have an object, and in terms of programming languages, an object basically describes something that has attributes, basically values that you can associate it with, and it also has functions. We talked about functions, so you should know what functions are. And this object can access its own attributes as well as the functions, right? So that's basically a summary of what an object is. So without getting into much detail about objects and stuff like that, we can talk about lists, for example. They are objects, right? We talked about lists in a previous video. And when you define a list, you can say, let's say we have a list called X. You can say x.clear. What you're doing here is you're saying this is an object, it's called X, and you're using the method or the function clear. Remember that we said that objects have functions. So as long as you have some sort of variable that has this capability of accessing its own functions or other attributes, then it qualifies to be called an object. Now, these objects are stored separately, or each object has its own memory location. And if you wanted to count from this, which is hexadecimal, stuff like that, don't really worry about this. Just focus on the last part. Let's say this is memory location 0, this is memory location 1. So if I say X equals to this list that just has integers, and I say Y equal to that, now this variable X stored here, Y is stored there, and we have identity operators which are is and is not. And what they check isn't if these two carry the same values. As you can see, they do carry the same values, but identity operators don't check that. They want to check if X and Y are pointing, or if they are stored in the same box. Now, as things stand, X has its own box, Y has its own box. So if you were to say X is Y, this would return false because they're not stored in the same memory location. But if you were to define X, then say Y equals X. Now, you haven't created Y from scratch such that it has its own memory. Y is just somewhere here, and it's still pointing, or it still accesses this X which is already there. So if you now say X is Y in this case, it should return true. So now is checks if the variables or the objects are the same object, or in other words, if they're stored in the same box or in the same memory location, and this just does the opposite. So if they're not in the same box, this will return true. So let's clear the screen and make sense of this. Is will return true if they're at the same memory location, or in the same box, stored in the same box, and is not, or return true if they're not in the same memory location. So it's basically the opposite. So let's investigate this, or let's look at what we can do with this information. Using the same example, we just have X with integers 1, 2, 3, then we have Y with integers 1, 2, 3 as well. Then we want to check, is X Y or is Y X, some sort of identity crisis, the term identity operator. So now X is trying to figure out if it's Y, but it's not, right? Because these are stored in separate locations. But as I said, if you were to say Y equals X and check this using that same print statement, we haven't changed anything in the print statement. We just said instead of Y having its own variables or its own list. It just takes the list which already belongs to X, which means it goes to the same box and says, okay, I am you, and that is why this is true. And in the other direction, if you say it's not, this will return false because currently they're the same thing. But if each one has their own location, then this will be true because is not does the opposite. It returns true when each of them have their own memory location. In this case, each of them do have their own memory location. That is why that is true. So that is all with regards to identity operators. They basically check if objects are equal, and basically that means that if objects are the same object and not necessarily the content of each of these. So we might also talk about comparison operators. So in terms of comparing, if X and Y have the same values, and if you'd use something like this to check if they do have the same values, that is what you do instead, right? To check if they have the same values inside. This is not an identity operator. It's part of a comparison operator that we talked about, and this now checks the content, which is what is inside. Identity operators check the object or where it is stored. So you need to know that difference, and that is basically how these things work. So that is all that I wanted to talk about in this video. I hope you could follow along. I hope you liked the video. If you did like the video, just give it a thumbs up. And if you haven't subscribed, please consider subscribing. And I'll see you in the next video.